This video is about interthread communication using C++ standard library. There are multiple ways to accomplish this. One is the condition variables. This is exactly similar to pthread condition variables. So you include mutex and condition variables, and then this is the sample code. You define a standard mutex and a standard condition variable, and then this is the variable that is the shared resource. So this is sample code where the thread ID is printed because two threads are waiting on it, and the third thread does ready so that the two threads which are waiting on this condition variable can go ahead and process the data, kind of simulation. So the print ID function, it does the log the mutex and then does a wait, and two threads basically, T1 and T2, and then the third thread actually sets that condition and then notifies all, which wakes up thread T1 and T2, and they print their output. So that is condition variables. Number two is mutex. Mutex you already see in the condition variables, uses the mutex. So here the counter is the shared resource. So you acquire the log and then increment it, and so when these two threads, whenever they get the log, they increment the counter and the counter is printed. Yeah, I'm surprised that there is no code to do unlock the mutex. Okay, third strategy is futures and promises. So this is under C++ concept. Basically the one thread does, hey, this is the thing of the future, the other thread promises that future. So that's the idea behind that. So you do std future result equals this async task. So it's sleeps for a second and then returns the value 42 just to simulate a task, and then this one waits until that one returns and it has the result.get. So this is the result is the future and this is the promise. So the fourth way is message queues. So using the std queues as a data structure, and then this is the producer consumer model. So producer produces data and then does the notification, and the consumer waits, and once the waits on this data, and then once the data is available, once you come here basically means you are out of this wait. The lock has been released at this point, and you pop the first element and then you say you consume it. So that is the message queue way of communication. And then C++ has atomic variables as well. So you define std atomic, so which allows only one thread to access it at a time, so no data corruption is involved or overwriting is involved. So it does increment the counter, and then both T1 and T2 increment the counter uh, like some 500 in an ideal way. If it's a fair share, 500 times it has been incremented by T1 and 500 times by T2, and then the counter will be properly at 100 here. Yeah, that's it. Thanks for watching. Please like and subscribe. Let me know if you have any questions or concerns. I'll see you in the next video. Bye.